Okay, so example 6 says determine the diameter of a water main with the same total area as two mains with radii of 3 inches and 4 inches. So we have a water main, for lack of a better name, this is just a big pipe. It's got some unknown radius, that's what they're telling us. The area of that pipe, the cross-sectional area, is the same total area as two different pipes with radii of 3 and 4 inches. So this would be a bigger pipe than those then, right? So we have pipe 1 has a 3-inch radius, and pipe 2 has a 4-inch radius. And this has some radius. This determines the diameter. Okay, I'm going to find the radius and then double it. So the diameter, I'm going to keep in mind here that diameter is equal to 2 times radius. So it's easy to find the radius, but then once I've found the radius, I simply make it times 2, right? The radius is 6, times 2 is 12. Radius is 1.9, times 2 is 3.8. So just whatever the radius is doubled. So it says the area of this unknown circle is the same area as these two put together. So I want to find the area of all three circles. What's the area formula for a circle? Pi r squared. So the area of the big circle, which is a sub b, is going to be pi r squared. We don't know what the radius is here. So that's the best I can do for that area formula. The area of the 3-inch radius circle, a sub, I'm going to say s for small, is pi times 3 squared. And the area of the middle sized one, a sub m, is going to be pi times 4 squared. So the area of the big circle equals the area of the two smaller circles. So if I've found all three areas, this area equals this area plus this area. So it's going to be pi r squared equals 9 pi plus 16 pi. They didn't give me the area formula. I knew the area formula because we've studied that chapter this year. We've studied circles in the past as well. Okay. But again, I took the relationship. The big area equals the two smaller areas. I found what I could find using a variable to represent what I don't know. Now, once I've written the equation, this is a common step in a lot of problems. We haven't done it so much this class, but it's something to look for when you see an equation. So let me just point this out so you can see that this is possible. When you have an equation, a bunch of objects, left and right hand side, pluses and minuses, whatever, and there's an equal sign in it, okay? And you see that each and every term contains the exact same object. There's 3 total terms. Every single term contains the letter pi, the term, the number pi. Okay. You are legally allowed to divide everything by that number if you feel like it, or multiply everything by some number. It doesn't matter, as long as you do it to everything. So if pi r squared equals 9 pi plus 16 pi, that means r squared equals 9 plus 16. Again, that is a legal algebraic step anytime you feel like it. If every single object in your equation contains the same factor, if they all divide by the same number evenly, you can do that division, and you're left with an easier equation. So if r squared equals 9 plus 16, that means r squared equals 25, which means r is equal to plus or minus 5 inches. Now, this problem, r is representing a length, and length makes sense as a positive number only, right? So the only answer that makes sense here is r is equal to 5 inches. It says find the diameter, so we're going to do double that. So the diameter of this pipe is going to equal 10 inches. Going back to this step here where I divide everything by pi, if I didn't do that step, I would have gotten pi r squared equals 25 pi, right? And at the next step, just like the last problem, I have a number times r squared. I'm going to divide by pi. R squared equals 25. You get the same place. Doesn't matter if you do it or not. I'm just saying if you recognize that, a lot of times when you do areas and circumferences of circles, there's a relationship there. Everything has a pi on it, so you can just take it out, get it out of the way. So the correct answer, diameter, is 10 inches. Again, we found the radius to be 5. We doubled it. And again, the negative answer doesn't make sense in the context of the problem, so we throw the negative answer out in this one.